In the first part of the solutions for the practice problems, we discussed the algebra problems. This is the second part of the practice problem sets. So we discuss in this one we discuss the trigonometric part. So as the first problem, we can talk about angle conversion problems. So we know that for so we know that radian, like if you look at the straight angle means the angle of straight line. So this angle has radian in radian, pi radians, and in degrees this is equals to degree 180 degrees. So this is this we can use as a standard relation. So from that we can find how much is 1 radian. To find 1 radian we can divide both sides by pi. So that means 1 radian is, we know we don't normally write radian, but here just exaggeration. So 1 radian is equals to 180 over pi degrees. And also to find 1 degree we can divide both sides by 180. So that means 1 degree is equals to pi over 180 radians. So this is we can use as a relation. So we have these two conversion relations. So let's see how we can use this in a problem. So for example, we can write, so for example we have, let's say pi over 3. So what is pi over 3 radian in radian? So what we're gonna do, so this is pi over 3, and then we know that 1 radian is equals to 180 over pi. So because we have this many radians, and then 1 radian equals to 180 over pi, and then you can see it simplifies very well. So pi and pi get cancelled, and then this is 3, so there are 60 of them. So that means so this is actually just 60, not 60 degrees. That means you're gonna get 60 degrees. And then on the other hand, let's say you have 15 degrees. So if you want to convert this, it is 15 times 1 degree. 1 degree equals to pi over 180. So and then you can see that this is how many, 15. So there are so there's a 115, and there are so we have, if you have 10, so it's 150, but there are two more. That means there are 12 of them. So that means it is pi over 12. So this is how you do a calculation. So let's see what are the problems that we need to do. So in the question 8, so we're going to do a first conversion to radian and then conversion to degrees. So let's look at the first part of the problem. Convert to radian. So this is one. Convert to radian. Convert to radian. So the first one is 72. So again, as we did, so we have 72, and then 1 degree we can write as pi over 180. And then we need to think about what are the how to cancel them. So you can see that there are 2 of 36. There are 2 36 here. There are 5 36 there. So you can divide by 36. So then you can see that this is simply 2 pi over 5. And then part B, so we have a negative 108. So this is again negative 108 times pi over 180. Again, think about how to cancel these. So you can see that there are 3 of 36. So there are 3 of 36, and there are 5 of 36. So that means it is negative 3 pi over 5. And then C, and if you cannot directly like a cancel like that, you can just find, you can see the 2 is a factor, so you can cancel by 2 first, then you get a smaller one, or you can divide by 3. So like you can do like that, then you can get a smaller and smaller. So that's one way to do that. If you cannot see these are multiple of 36, just like divide by 2 first, or 3, so things like that. You can divide by 3 or 2, so then you can get smaller, then you can see what are the common factors. So that's another way to do it. And then how about this one, 382.5. So this may be easy to like kind of split this. You can see that this is simply 360 plus 22.5. Why we do that? 360 means 2 pi, you can write it directly, and then 25.5 is half of 45. So 45 means pi over 4, so you want to take half of that. So this is like another way to do that without using the conversion factors. Now this is easy to solve. So this is 2 pi plus pi over 8. So that means it is 8 times 2, 16 plus 1. So this is 17 pi over 8. So that's that way you can simplify that. Okay, so that's the first part. So let's go to the second part. What we can do, we can convert to degrees. So convert to degrees. Convert to degrees. So the first one is 7 pi over 6. So this you can write as like as before. So you can see, so this is degrees. So that means 7 pi over 6 times, we know that the one, so we will convert degrees. So one radian is 180 over pi many degrees. So that means now again after that we can do cancellation, so you can cancel that, and also 6 cancels with 180, there are 30 of them. So that means we have 7 times 30, so which is 2010. And then part B, so we have 27 pi over 12, and again as before we have 27 pi over 12 times 180 over pi. So again you're gonna cancel that, and then 12. How many 12? So you can see there are 1 of them, and then there are 15 of them. So then what you can do, you have 27 times 15, so which is 375 degrees. And as the last one we have negative 7 pi, negative 7 pi over 12. Some numbers that have some common factors, times again 180 over pi. So you can see this get cancelled. Again this there's a 1 and there are 15 of them, so it is negative 7 times 15, which is negative 105. So certificate. Okay, so that's about that. So let's go to the next problem. Next problem is about how to find, so let's say you are given a point, and then you're going to find all the 6 ratios. So let's talk about quickly what are the related theories about that. So in this problem we can find the trigonometric ratios in each quadrant. So let's look at the 4 quadrants. So in the first quadrant, let's say if you have a point, so also you can connect it and then drop the perpendicular. So this is how it looks like. So that's the point. And then so this is the y coordinate, the x coordinate, and the r. So we can write the 6 ratios using these three values. So you can write all the ratios. So you can write sine, let's say the angle is theta, so sine theta is y over r, and then cosecant theta is r over y, and then we have cosine theta, which is x over r, and then secant theta, which is r over x, then tan theta, which is y over x, so cotangent theta, which is x over y. So that means you just need to know the x, y, and r, those three values, and you can in ratio. So it doesn't matter in what quadrant you have. This also give you the appropriate sign. So this is quadrant 1, and if you go to quadrant 2, so this is quadrant 2, and then quadrant 3 and quadrant 4. So it's easy to remember like that. So if in quadrant 2 like it's gonna look like that. So we drop the perpendicular, and then this is the y coordinate. X coordinate is negative in this case, and then r. So your angle looks like that. So if you know the values, you can just write any ratio like that. And in third quadrant, your angle gonna look like this. So that is the perpendicular. You drop the perpendicular. So it is x is negative in this case, y is also negative, r positive. So knowing this, you can find the 6 ratios, and in the fourth quadrant it looks like that. So again, so this is the y coordinate, the x coordinate, and the r. So in the fourth quadrant the angle looks like that, and again knowing x, y, z, you can find any of those ratios. So let's look at the problems now. So in this problem it says to find the 6 trigonometric values, trigonometric ratios, actually find the 6 trigonometric ratios. So the point is given, asking what are the ratios. So we're gonna draw in each quadrant. So the first one is in the first part, the point is at -3, 5. So if you draw it, you're gonna get, this is second quadrant, so that's the angle. What we normally do is we drop the perpendicular. So let's put the information given. So it is the x coordinate is -3, the y coordinate is 5. What you need to find is the radius. So from the Pythagorean identity, the r you can find as r squared is equals to 5 squared plus -3 squared, so which is 25 plus 9, that means 34. Since r is positive, we get the positive square root. That means this is 34 square root. Okay, since we know all three sides, you can find any ratio you want. So we're gonna go with sine theta is at the y coordinate over r, so that means 5 over 34 square root. Rationalization is not a must, so you can leave it like that. And then upside down, you get the cosecant, which is r over y, which is 34 square root over 5. And then cosine theta, which is x over r, which is -3 over 34 square root, and the secant theta, which is r over x, which is 34 square root, and there's a negative sign, over 3, and then tan theta, which is y over x. So in this case, y is 5 over -3, so you can write this one as, so it's 5 over -3. What we normally do, we write the negative sign in front, so negative 5/3, negative 5/3. Okay, and then cotangent, so is x over y, then we're going to flip over the -3/5. So those are the values for the first one. So let's look at the second part. Part B. So we have the point P equal -3, -1. So that's a point, and you can see that this is on the third quadrant because both coordinates are negative. So like that. Again, as before, we drop the perpendicular. So this is -3, -1, -3, -1, and then so x is -3, y is -1. So the angle is this. Good. So we again need to find the r, the radius. So that means r squared equal -3 squared plus -1 squared. So which is 9 plus 1 equal 10. That means r, which is square root 10. We only consider the positive one because r is always positive. So since you know all three sides now, so you can find any ratio you want. So again, as before, so let's call this angle alpha, just to make a difference in the previous one. So that means sine alpha, so which is y over r, that means -1 over square root 10, and the cosecant alpha, you can make it upside down, so it's -10 square root, and then cosine alpha, which is x over r, which is -3 over square root 10. Secant alpha is the reciprocal of cosine, that means we can upside down, so it is negative square root 10 over 3. And then tangent, so tan alpha, which is y over x, so y coordinate over x coordinate, and you can see it, which is -1 over -3. So the negative sign cancel out, so it's become 1/3. That's not enough space, so let me write again. So we have the y coordinate over x coordinate, so y coordinate is -1 over x coordinate -3. The negative get cancelled, so it becomes 1/3. And then cotangent alpha, which is upside down, which is 3. Okay, so let's go to the last part of that. So part C. In part C, we have the point at 2, -5. So which is this one. It's in you can see it's x is positive, y is negative. That means it's in the fourth quadrant. So that's the angle. I'm going to call this beta. So again, drop the perpendicular to the x-axis. So let's put the data. We have the x coordinate is 2, y coordinate is -5. Again, we need to find the radius, the r, which is r squared is by the Pythagorean identity 2 squared plus -5 squared. So which is 4 plus 25, which is 29. So r is 29 square root because it is positive. And then we can find sine beta, so which is y over r, so which is -5 over 29 square root, and then the reciprocal of this is cosecant beta, which is -29 square root over 5, and then cosine beta, which is x over r, which is 2 over 29 square root, and the secant beta, which is square root 29 over 2, and then tan beta, y over x, so which is negative 5 divided by 2, and then cotangent beta, which is negative 2 over 5. Okay, so let's go to the next question. In the next question, what we're going to do, we're going to find various trigonometric ratios, uh, like for different angles. So this is the general formula. So like, let's say for example, if you have f theta equal like you're gonna what we normally do, like if you have function trigonometric functions, we normally write this one as, so you can always write this one as plus or minus f the reference angles. That's the technique what we normally use here. And you can see that the sign, this sign we're gonna find using the ASTC argument, so that we discussed earlier. So ASTC argument gonna give you the sign, and then to find the function trigonometric function value at the reference angle, we're gonna use the table on the right. So this part simply coming from the table, and also this table is the common trigonometric values that we normally use. And then you can see that so there are certain patterns here, like for example, if you if you reverse the values in the sine, you're going to get the values in the cosine. That's one of the common practice. And also you can see that to get the sine values, what you normally do is you're going to write 0, 1, 2, 3 and 4, and then what we can do, we can divide everyone by 4. We divide each number by 4. So write 0 to 4, divide by 4, and take the square root. Once you do that, you can see that these are the values in the sine table. So you can see these are exactly the values in the sine table from 0 to 90 degrees. And then to get the cosine values, you reverse the order. So this is the trick you can use. You write 0 to 1, 2, 3, 4, and then divide by 4 and take the square root. And then to find the values for multiples of pi over 2, to find the values of multiple of pi over 2, we use the unit circle. So so use the unit circle. So that's what those are the common things that we use. So unit circle means the circle with the radius 1. And then you can see that the cosine is the x coordinate, sine is the y coordinate, tan is the you're going to divide the quotient of the y coordinate over x coordinate if it is defined. So you can see, you can find all the values using this. So these are the things that you need to remember, and you can see using these you can easily solve any problem of this type. So let's also look at the quadrant. What happened in the quadrant? So so to find the reference angle, so let's say, so these are the reference angles. So the question is, if you know the reference angle, how to find the angle? So for example, so you can see that in the first quadrant, so the angle is simply theta r, and then you can add multiples of 2 pi. But here just I'm writing the principal values, and then here you can see the principal value is simply, so so this is the 0, and then this is we normally write this as pi. So this is also pi. This is 2 pi. So you can see for at this time in the quadrant 2, your value is simply theta equal pi minus the reference angle. That's what happened for the quadrant 2. For the quadrant 3, you can see that theta is simply pi plus the reference angle for the quadrant 3, because pi and a little bit more than like pi plus theta r, the reference angle. And for the quadrant 4, you can see it is 2 pi minus the reference angle. So those are the 3 cases, and you can see that we're going to use this a lot depending on the situation. And these are the principal values. To get the other values, what we normally do, we're going to add multiples of 2 pi or multiples of 360 depending on the radian or degrees that we work with. So let's try to look at several problems now. Knowing those, we can find these values now. So let's start with the first one. So we have sine, so we can find exact values. So sine 2 pi over 3. So we have sine 2 pi over 3. So we first draw the angle, and you can see that this angle is on the second quadrant. So that's the angle, theta. So what we need is so we know that by the ASTC, so this is in the, this is a sine, as by ASTC, and you can see this is sine, which is in the second quadrant, so it has to be positive. And then sine, what we need is a reference angle. So since this is 2 pi over 3, so let's count. So you can see that, so you're gonna go with 0. What we're gonna do, we're gonna count multiples of the denominator. Denominator is 3, so 0, 3, but you can see that it's not 3, it's 2. We have 2 here. That means the reference angle is simply this part. So it is pi over 3 is the reference angle. So that means, so now this is gonna be according to the formula, this is simply the reference angle here, which is pi over 3. Now the thing is that you can find this using the table. So that's why, so we use ASTC and the table to evaluate all of these. So this is what we normally call the reference angle method. So this is, according to the table, this is square root 3 over 2. So let's look at the next one. Next one is cosine 5 pi over 3. Again, what we can do, we can look at the multiples of the bottom. So we're going to go with 0, and then 3, and then you can see it's 5. So that means you have to go to the next one, 6. So since it's 5, it didn't go to the first quadrant, it stay with the fourth quadrant because it is 5. So that's the angle. And then again you can see the reference angle is pi over 3 in this case. Good. So now what we know is this is in the second quadrant, and it is a cosine. So according to ASTC, which has a positive sign, because a cosine is in the fourth quadrant, so that is positive. And then cosine, the reference angle, pi over 3. So according to the table, this is going to be cosine pi over 3 means 1/2. So that is the exact value of this. So let's look at the next one. Let's see. So we have tan negative 5 pi over 6. So negative means it's going to go counterclockwise. It's going to go clockwise. That's what negative means. It's going to go clockwise. So let's see how it works. So we look at the multiples of the denominator. So we can start with 0, and then 6. Since it is 5, it's in the in this case third quadrant, because we're going to count backward. So that's the angle. So and then the reference angle is pi over 6. So that's the angle. Theta. So which is a negative angle. It is negative 5 pi over 6. Okay, now we can, so it's a tan. Again, according to ASTC, so T is in the third quadrant. So this is a positive one. Positive tan, the reference angle, which is pi over 6. And from the table, we know what is tan pi over 6, which is 1 over square root 3. Let's go to the next one, part D, which is cosecant 5 pi over 3. Again, see where is the angle. So we're going to count by multiples of 3. So it is 0, 3, and 6. Since it's 5, it has to be on the fourth quadrant. So that is the angle. Again, the reference angle is pi over 3. So, but now We don't know cosecant we can directly find. So what we can do, we can write 1 over sine 5 pi over 3. Now what we can do is, now we can use it. So by the ASTC, so this should have a negative sign, and then sine the reference angle pi over 3. So which you can find, so 1 over minus sine pi over 3 means square root 3 over 2, and then writing is upside down, you can see that negative 2 over square root 3. So you just make it upside down. It's a reciprocal. Good. So let's go to the next one. So in part E, we have a secant negative 5 pi over 4. Again, that's a negative value, so that means gonna go clockwise. So let's look at multiples of 4. So it is 0, 4, but didn't go up to 6 is 5. That means it's gonna stay in the second quadrant. So that is the angle. So the reference angle is pi over 4. And then we have all the information we need. So it's a secant. So according to ASTC, secant has the exact same sign as the cosine, but this is the second quadrant. So that means secant is negative. So which is negative secant the reference angle, which is pi over 4. And then what we can do is, this is now negative. Secant means 1 over cosine pi over 4. So again, so what's the argument? Secant has the exact same sign as the cosine. Cosecant has the exact same sign as the sine. Cotangent has the exact same sign as the tangent. So it's a negative, and then we're going to plug in the value, which is 1 over square root 2 negative. So that means this is negative square root 2. So we can do it like that. Good. So let's go to the next one, F. So as the next one, we have cotangent. So we're going to find the cotangent, 13 pi over 6. So let's again see where the angle is in. So we can look at the multiples of 6. So it is 0, 6, and the 12. 13 means just little more. So that means the angle has to be there. So it's 0, go like that, and so that's the angle. So go one full cycle and go a little bit more. And the reference angle is again pi over 6. So that is pi over 6. So it's a cotangent. Actually, it's a first quadrant, so all positive. So this is cotangent. The reference angle, cotangent is 1 over tangent, and then this is 1 over square root 3 from the table. So that means this is square root 3. So let's go to the next one. So we have G, which is we're going to find cosine negative 2 pi over 3. So again, so you can draw the angle. So you can see that as we did the argument, is 0, 3. So it's not 3, is 2. So that means it's going to go a little over there. So that's the angle, which is a negative angle, and the reference angle is pi over 3. Which is a cosine, but the third quadrant, so which is negative. Cosine the reference angle, so that means this is negative. Cosine pi over 3 is 1/2, so the value is negative 1/2. And then the last one, H, so which is sine 25 pi over 3. So I'm going to do this a little different way. So 25 means 24 plus 1 pi over 3. So now this is, you can write this one as 24 over 3. So that means which is 8 pi plus pi over 3. So we can write it like that. So we since sine has a period 2 pi, any multiples of 2 pi you can cancel out. So that means 8 pi cancel out. So that means you can simply write this one as sine pi over 3. So which is square root 3 over 2. Okay. But if you have a different other areas like other quadrant, we can do a different way. So you can see that. So if you want to draw the angle, so what happened? It's gonna go like 8 cycles. It's gonna go like 8 cycles like that. So you can go 8 of them, and then you can stop in that quadrant. So there are 8 cycles here. So that's how the angle looks like in this case. So there are 8 cycles, and then just a little bit of pi over 3 here. Good. Okay. So that's how you do the problem. So let's go to the next one. This is again a very typical problem. So what we normally do is you're gonna get you're gonna get one ratio and some other condition. Either it might say something like that, or they might give you the where the angle lies, in what quadrant the angle lies. So these are the kind of questions. You're gonna get one trig ratio and a condition for the angle. So let's look at the first one. So you can see that what it says that sine theta equal 1/3, sine theta equal 1/3, and then tan theta is negative. So that means if you look at those two conditions, sine is 1/3. That means it is on the so sine positive. That means to be in either first or the second quadrant. Tan negative means it should be in the either second quadrant or the fourth quadrant. So that and then you can see that only the second quadrant is common. So that's where the angle lies. So using that fact, what we're gonna do now is we're gonna draw the angle. So it's in the second quadrant, so it's gonna look like that. And then we drop the perpendicular. So this is the angle. Now what we're gonna do is we're gonna put this information. So sine is opposite over adjacent, opposite over hypotenuse. So it is 1, 3. So the goal is to find the other side that you can easily find using the Pythagorean identity. So it is r squared equal 1 squared. So in this case, actually, we can write it like that. So because r is given, so we need to find the other side. So we can see that 3 squared equal 1 squared plus x squared. So then this is the x squared is 8. So x is, and then you can see that x is negative. Since x is negative, when you take the square root, you only take the negative square root here. So it is negative 2 square root 2. And after that, and then you can see that now we know. So we just use the Pythagorean identity, and then now we know it is. Now we know all three sides, so we can write any ratio you want. Okay, so again, so what we did, using the given information, we figure out what quadrant the angle is in, and then after that we draw the angle in that quadrant. And then after we do that, then we can just use, we find the other ratio, other side, using the Pythagorean identity, and then after you can find any ratio you want. Since we know all three sides, now you can write sine theta, which is 1/3, and then cosecant theta, which is upside down, which is 3, and then cosine theta, which is negative 2 square root 2 over 3, and the tan theta, which is negative 1 over 2 square root 2, and then secant theta, so which is negative 3 over 2 square root 2, cotangent theta, which is negative 2 square root 2 by upside down. Okay, so we can write any ratio like this. So let's look at the next part. In part B, so it's again very similar to what we did. So you are given these two information. So one is tan is given. So tan theta, which is equals 1/2, and also it says that the angle is in between pi and 3 pi over 2. So which says that actually it says where the angle lies in. It is in the third quadrant. So we can just draw the angle in the third quadrant in this case. So that's the angle, and then again drop the perpendicular. So we use the information given. Tan is 1/2, but you have to be careful. You cannot just write opposite and adjacent, because both has to be negative, so you put negative sign in front. So that's something you have to be careful in this case. And again, I use the r value, and you can see that r squared is simply -1 squared and -2 squared. So so you get 5. So that means r is square root 5. R we always get as a positive value. Okay, now we know all three sides, so we can write the ratios. So sine theta is -1 over square root 5. Cosine theta is -2 over square root 5, and tan theta is -1 over -2. So that means 1/2, which is already given. So, and then cosecant theta upside down, and then secant theta, which is negative square root 5 over 2, and the cotangent theta, which is 2. Okay, so the last part, which says that cosine theta is 1/4, and cosecant theta is negative. Cosecant is negative. Good. So that means using that information, cosine theta negative means this says that sine theta negative, because that's just the reciprocal, because sine theta means 1 over cosecant theta. So that means it has to be -2. So that means sine negative, cosine positive means the angle is in the fourth quadrant. So that's what we figure out. Angle is in the fourth quadrant. So like that. So that's the angle. And then we're going to put the information there. Cosine theta, which is adjacent over hypotenuse. And then we can use the Pythagorean identity again to find the other side. So that means y, the other side is y squared is 4 squared minus 1 squared. So that means it is 15. So that means it's a negative value, so it's a negative square root 15. So we find all three sides, so we can write the ratios we want. So we have sine theta equal negative square root 15 over 4. Cosine theta is 1 over 4, and then tan theta is negative square root 15, and the cosecant theta, which is negative 4 over square root 15. Secant theta is 4, and cotangent theta is -1 over square root 15. Okay, so those are the values we get. So let's go to the next problem. Next problem is about graphing trigonometric functions.